Okay, so this week we're going to talk about a different kind of form of logic. It's actually older than the form of logic that you guys were doing last week with the propositional logic. And this form of logic is known as categorical logic. So when we talk about categorical, we're talking about propositions that deal with classes of things. That is, things that share a certain, they're grouped by sharing a certain characteristic, right? Now, categorical logic is also known as classical logic, and classical logic goes all the way back to Aristotle. The propositional logic that you guys were doing last week with the truth tables and the conditionals, the disjunctions, the conjunctions, etc. That particular form of logic really was more fully developed in the early 20th century. So the categorical logic that we're going to talk this week is actually, we're kind of going back in time in terms of the kind of version of logic to use. And we need categorical logic because, say for instance, you have something like a claim like, let's put it over here, something like all cats are mammals. Let's see, all mammals are furry animals. Therefore, all cats are furry animals. Now, if we're just left to the propositional logic that you guys learned last week, there's not really anything we can do with these particular propositions. And this is because you might say, well, okay, well, all cats are mammals. Well, that has to be a kind of conditional statement, all right? But, so you might say, if C, then P, or then M, to symbolize mammals, all right? But the problem with that is that this isn't referring to, this particular statement is not referring to, the cats is not, this is not completely covered by the proposition of C, right? So this is really representing, a particular part, but the cats is really falling into a category of mammals, right? So there is some ways in which you can kind of translate this to make this work, but the particular propositional logic that you guys use is really limited in what I can do. You also cannot do something like the following, where you say, okay, well, I'm just going to symbolize this whole proposition by saying that it is equal to C, and this whole proposition, all mammals are furry animals, by saying that it's, F, and then therefore all cats are furry animals, and then saying again, well, let's make this one M, making this F. Basically, there's no way you can make this into a single proposition, right? Because then you really don't have an argument at all. So we need a kind of different form of logic in order to, accommodate for statements that are discussing categories of objects, right? Okay. So this is what we're going to be sort of talking about this week. Now, before we begin on this, actually doing syllogisms and trying to determine the validity, as we did, we're going to determine the validity in the similar way in which we tried to determine the validity of propositional statements. We're going to try to determine the validity of categorical statements. But in order to actually get to that point, in order to do that, we need to first sort of discuss the individual parts of categorical syllogisms, and those individual parts would be the propositions themselves. All right. So there are really four kinds of categorical propositions, and in this video I'll talk about the what is known as the A and the E propositions. All right. So let's begin with what are known as the universal affirmative propositions. So what these propositions are saying is all the members of one class are included in another class. Right? So these particular propositions take the form of, let's see here, grab a cloth here. We might need a little more space. All of these propositions take the form of all S is P, right? Right. Now we're using these particular letters because S is referring to the subject of a sentence, whereas P is referring to the predicate of that sentence. Right? Okay. So an example of a universal affirmative proposition would be something like, kind of like what we used in that example before, all cats are mammals. Now, your book will use what's the Venn diagram method in order to symbolize this. As you'll see in the later videos, I have a different kind of method of determining validity that I think is a little bit quicker to understand. But in order to symbolize what each individual proposition looks like, it's kind of helpful to use a Venn diagram here. So the way we would do this, as your book demonstrates here, is that this side would be anything in the subject, this side would be anything, this circle includes anything in the predicate, right? So subject being here cats, and predicate being mammals. Now, when it comes to universal affirmative propositions, what we're saying then, in order to symbolize this, is that there will never be a case where you will find a cat and it won't be a mammal. So that's why we're putting lines through the side of the Venn diagram that just includes the subject term. Anything that you find that is a cat is going to have to be a mammal, right? So it's going to be included within the overlap there, all right? Now, we refer to these universal affirmative propositions as A propositions. That's just our shorthand for what these propositions are. And the reason why we call these A, and I'll discuss why we use these letters to denote these certain propositions, it actually goes, there's at least reason to believe it goes back to the Latin. So the Latin here, affirmo, it was just a shorthand for medieval logicians to sort of remember this. They used the A in the word affirmo, like affirmative here, to remember these certain propositions. Right? So these are the universal affirmative propositions. All right. So the other kinds of propositions that we have, that we deal with here, are known as universal negative propositions. Universal negative propositions. So with these particular, and let me make that clear, with these particular propositions, what we're saying is no members of one class will be included in the other. Get another marker here since this one seems to be dying. Okay. All right. So again, the standard form of these particular propositions is no S is P. Right? So for example, you could have something like no cats are reptiles. Right? So again, with our Venn diagrams here, what we're going to say, again, same placement, subject, predicate, with the subject being cats, and the predicate being reptiles. What this is basically saying is that there will never be a case where there's overlap between the subject and the predicate circles. So basically, there will never be a case where you will find a cat, and that cat will be a member of the reptile class, right? So that's basically how to symbolize these particular propositions. And like the universal affirmative propositions we discussed, this too has a shorthand known as E propositions. And we also kind of maybe have a little historical reason for why this is the case, and it goes back to the Latin term amigo, right, where, again, they're using the E as a shorthand for remembering this form of proposition.